Hello everyone, welcome back to my YouTube channel. This is Sandeep Kumar from Sri Venkateshwara College of Engineering. Today we are discussing about vision of how digital image processing enable self-driving cars. In the existing world of vehicles, digital image processing plays a pivotal role. It has eyes of self-driving cars, enables them to perceive and understand their surrounding, make information decision and navigation complex environment safety. This presentation delves into the fascinating world of digital image processing in the self-driving cars, exploring its core functionalities and the impact it has on the future of transportation. And coming to the understanding the environmental through computer vision or image acquisition, image processing, feature extractions. The journey begins with the image acquisition where the cameras mounted on the vehicles capture real time images of the environment. These cameras are strategically positioned to provide a wide field of view capturing essential details like lanes, roads, signals, traffic lights, and surrounding vehicles. And the image processing, capturing imaging are not always perfect. They can be noisy, distracted, or having varying lightly conditions. Image processing techniques like noise reduction, image enhancement, and color correction and apply to improve image quality and prepare them for future analysis. And feature extraction. Once image is proceeded, the next step is extract key features that provide meaningful information about the environment. This involves identifying edges, lines, corners, and other geometric shapes that defines object and their relationship when within the scene. And coming to the detecting and classifying object in the real time or object detection, object classification, and deep learning techniques and the real time performance. The object detection is a object detection algorithm scans image to pinpoint the location and the size of object and interest like car road signs. This achieved by the identifying pattern and the future assessment with the specific object. And object classification. Once object or detection they are needed to be classified. This involves in assigning a label to each object in identifying its specific type. For example, identifying is a whereas of a cyclist or stop signs versus yield signs. And coming to the deep learning techniques are modern objects detection and the classification system and often leverage deep learning techniques, partially conventional neural networks. Uh, these networks are trained to massive data sets of images, allowing them to learn complex patterns and make highly accurate. And coming to the tracking moving objects and predicting their uh, trackages. Object tracking, column filters, and treasury predictions. And the sensors fusion, combining data from the multiple sensors or camera sensors, laser sensors, and radar sensors, and ultrasonic sensors. Camera provides visual information about the environment, allowing their cars recognize objects, read signs, and understanding the landmarking. They are critical to uh, tasks like object detection, classification of land keeping. And the radar sensors are used to radio wave to detect object and measure their distance, speed, their partial effect in the detecting object at longer range in the adverse weather conditions, providing complementary information to the camera and lidars. And coming to the ultrasonic sensors, the ultrasonic sensors emit the sound waves and measures the time to taken for them, return providing information about the proxy of objects that are commonly used in the smart range, short range obstacles detection, partially in the parking and low speed scenarios, and the localizing and mapping for navigation, and the locationization and mapping sensor integration. And the location is refers to the ability to determine its precision, precise position and orientation within the world. And the mapping is involves in the creating a details representation of environment, including roads, buildings, obstacles, and other relevant features. And the sensor integrations are localization and the mapping really on the integration of data from multiple sensors, including camera, lasers, and the GPS. And the path planning and decision making algorithms are a search and the algorithms, dynamic programming, reinforcement learning are the functions are finding the optical path between the 2 points, considering the distance between the obstacles, determine the short path from the starting point to the all other nodes in the graphs, and the breaking down a complex path planning problem into the smaller interconnected superproblems, and the trains the car to make optical decisions throughout the trial and the error, learning for the past experience. And coming to the handling, challenging environmental conditions are fog and rain, and the sun and shadows, and the darkness, and snow and ice. Fog and rain can be severely reduce visibility, make it challenging for cameras to identify the objects, and the sunlight or strong shadows can cause reflection and distractions in the image, making the object detection difficult. And the darkness in the low light or nighttime conditions, cameras struggle to capture the sufficient details, and the snow and the ice can be reflect light into the unprecedented way, creating challenges for object detection and localization. And coming to the ensuring safety and reliability throughout the redundancy, multiple sensors, backup system, and the safety features, and continuous testing and validation. Multiple sensors, using multiple sensors like cameras, lasers, and the radar provides the redundancy, ensuring that if one sensor fails, the car can be still rely on the other for accurate precision and navigation. And the backup system, self-driving car are equipped within the backup system are crucial component, ensuring that car can be continue to operate safely in the events or of a failure. And the safety features are advancing safety features like automatic emerging braking, lane um, depression warning, and adaptive cruise control, providing an extra layer for the protection. And the continuous testing and validations are self-driving cars undergo readiness and testing and validation to ensure their safety and reliability. Finally, I am coming to the features of digital image processing in autonomous vehicle. The features of digital image processing in the self-driving cars is bright, driven by the ongoing advancement in the artificial intelligence, deep learning, and the sensor technology. Here, the glimpse is the potential impact enhancements, object recognition, and prediction and navigation, and real-time environment awareness, and the increasing uh, automation. These are the features of digital image processing in the autonomous vehicles. And this is the video. Thank you for watching.